So in this video, we're going to try question 25, and these are a little bit more complex reaction scenarios. And so I've got lead strip, so that's lead solid, is placed in copper 2 sulfate solution. So it's got copper 2 ions and sulfate ions in water. So what I need to do is take my data booklet and go find all of those things. Now I've done this one already for you. I've got water and water. Water and sulfate form an oxidizing agent, but they're a pretty weak oxidizing agent. So I'm going to start listing things. Water is an oxidizing agent and a reducing agent. I've got sulfate and water. So together, those are an oxidizing agent. I've got lead and sulfate are a reducing agent. Lead itself is a reducing agent. And copper 2 here is an oxidizing agent. So those are all the agents. But copper 2 is obviously my strongest oxidizing agent because it's on the top left-hand spot of all of my oxidizing agents. And my strongest reducing agent is actually lead and sulfate together. So my strongest reducing agent is the lead with the sulfates. It's a little bit better than just lead by itself. So now I'm going to take those half reactions. I've got copper 2 ion plus 2 electrons makes copper. That's reading this reaction forward because that's the gain of electrons reduction. That's my oxidizing agent. And then I've got my lead and sulfate. So lead, solid, and sulfate. Those are the entities that I've got that can react, will become lead sulfate, solid. And this is the losing electrons oxidizing, that's my reducing agent. And, and it has 2 electrons. So the electrons are balanced, so I don't need to do anything to balance the coefficients. I've got lead and copper 2 and sulfate will, so aqueous, sorry. Solid aqueous will make copper solid and lead to sulfate solid. And because the reaction is like this, it is a spontaneous reaction, right? And so we're able to take a list of entities and translate that into our reaction. And we'll see if we can do another one. It probably won't be quite as quick, but let's take a look at the C. So for C, it says potassium dichromate solution. So that's going to be potassium ions and dichromate, which is Cr2O7 negative AQ. It's a solution, so we know we've got water is present. Is added to an acidic. So if it's acidic, it has hydrogen ions. And iron 2 nitrate solution. So iron 2 ions, and there are going to be nitrate ions. So this has got a load of entities in it. So we're going to have to organize our entities, and I always know that I've got my water, so as long as it's in an aqueous solution, and then I need to organize the others. So this is going to be a little bit more involved for finding our entities, and practicing this is really an important skill because we end up needing to find these chemicals in a pinch, and that's not always easy. So I've got my waters. I always have my waters. Potassium is a terrible oxidizing agent. It's an oxidizing agent, but it is the second worst oxidizing agent. It's way down here. So I'm not even going to put a label beside it. But dichromate here with acid particles are a great oxidizing agent. They will be my strongest oxidizing agent. They're super high on this list. I've got hydrogen ions, and hydrogen ions are here. So I'm going to put a little label beside my dichromate and my acid because that is spontaneous. My acid particles are also going to become hydrogen gas, so that's a common one. So my hydrogens are an oxidizing agent. Iron 2 is listed here, so it's an oxidizing agent, but it's further down than this, so it's not going to be my strongest. So my iron 2 is going to be there. I also have nitric acid is hydrogen ions and nitrates, and those are listed here. So that is also actually quite a strong oxidizing agent. This is an oxidizing agent. So you can see how this starts to get quite complex, and water is both an oxidizing agent and a reducing agent. I need to keep track of it all. Now, if I go to the reducing agents, my water is a reducing agent. This won't be, this won't be, this is, this isn't. This can be though. So iron 2 is listed in both columns because it could lose an electron and become iron 3, or it can become iron. So it's both a reducing agent and an oxidizing agent. And in fact, iron 2 is my strongest reducing agent, so I'm going to have this become this and this become this. So I write down my two half reactions. I get dichromate ion plus 14 hydrogens plus 6 electrons becomes 2 chromium 3 ions and 7 waters. And that is the gain of electrons reduction, my oxidizing agent. And then my iron 2 is going to act as the reducing agent. It's over here. And this will be spontaneous because it's got that left-hand rule. So I've got my iron 2 is becoming iron 3s plus an electron. That's the loss of electrons, oxidizing, reducing agent. And to balance this, I need to balance my electrons. Since this is 1 and this is 6, I need to multiply this by 6. I get dichromate ion plus 14 hydrogen ions plus 6 iron 2s become 2 chromium 3 ions plus 7 waters plus 6 iron 3s, and I'm done. This is a spontaneous reaction, again, because of the left-hand rule. So this is quite involved, and you can see the key is finding all the entities and then finding their location in the data booklet. Stickies can help out, but really this is such a strong oxidizing agent that it's fairly clear that's going to be my strongest oxidizing agent. There are only a few things that are still stronger than that. So anyhow, hopefully that helps.